Hello and welcome to our Improving Talks session. Good afternoon, everyone, and thank you for joining us today as we start the last week of our very awesome Tomorrow Technology Today Improving Talks 12-part series, designed to communicate to our clients, employees, and all of our stakeholders on improving point of view and capabilities. My name is Armando Lopez, and I am very honored to welcome you today. But speaking of the man of the hour, Michael Slater. He's a technology leader with a background in software development. His expertise is helping lead and organize teams to solve problems with software, ensuring that teams establish and continuously improve the software delivery lifecycle through best practices in software design, product management, and DevOps. He also has a passion for projects that include data engineering, data science, and machine learning components, and enjoys the hard work of putting together complex software solutions. Michael also loves spending his free time raising his two boys and riding bikes. I am very happy to welcome him today with his webinar, Agentic Workflows in Business, the Evolution of AI Chatbots. Before we start, I encourage you to use our Q&A feature so you can ask him questions, which he will be answering until the end in his Q&A section. And now I leave you with Michael Slater. The microphone is yours, my friend.
All right. Thank you for the introduction, and we'll get going. So Michael Slater, I am Technical Director at Improving. I specialize in our AI engineering practice. What that means is I like bringing products to market, specifically products that have some kind of AI or data science type component. I specialize in AI and machine learning, and leading software engineering teams to build AI-based products. At Improving, we have a vast array of capabilities in engineering, QA, mobile, cloud development, AI development. If you're ever interested in having Improving help you develop a product, please reach out to me. So a brief overview of AI and machine learning. I always like to start a lot of my talks with this slide, which is what we think AI is, but what it really is. Terminator on the left, classic AI representation in our pop culture from the Terminator movies, which is some kind of ruthless machine. It's focused, it's smart, strategic, tactical, but it's not really what AI is in our systems today. We are more like Bender from Futurama here, where we have personality, kind of get distracted, vastly capable, strong, still a smart robot, but without a lot of guidance, don't really know where to go. And kind of what I like to say in this message is AI represents who we are, right? Especially language models. It's representing the language we have out on the internet and the behaviors that we represent. So AI is what we make of it. Now, when we talk about AI versus machine learning, these are kind of two fundamental different concepts, but of course they're very closely related and affect each other. Artificial intelligence is the input of rules and data to get answers. When you use an AI product, you expect to give it data and it's going to follow rules and you want answers. However, in order to build AI products, machine learning engineers and data scientists must build machine learning models. That is, we must take data about the world and answers to that data and develop the rules that the AI systems can use. Right? So to have great AI, you usually need machine learning first. And a complex AI system may be composed of multiple machine learning models, as well as other AI techniques that solve specific problems within the ecosystem of that space and are composed together to form an intelligent system. Further diving into that, we have multiple levels of where AIs come from today. We have machine learning, which in classic machine learning is very rooted in statistics-based systems and mathematics, like decision trees, logistic regressions, linear algebra, etc. But the AI you hear about today, such as Gen AI, large language models, etc., are built with deep learning AI. And that is a subset of machine learning that uses neural networks to have vastly greater capabilities using vastly more data to create what we know today. Now, foundational models, and we call them foundational models because we like to say that they have a foundation of human knowledge. And that is usually a broad foundation, like if you're using ChatGPT and everything, or if you're creating a model for a specific purpose, like medical, industrial, etc., it may at least have a foundational amount of knowledge in that area. And what you get from these foundational models is a suite of capabilities, such as text generation, right? Be able to prompt and have it create text from the fly. We like to say that in text generation, given the start of a story, AI can finish the end. There's also chatbots. That's the way many of us enjoy working with these generational AI models today via ChatGPT, Claude, Gemini, or any of those other chatbot models out there that you can use. But a big part of this talk is really focusing on search and text summarization. And that is building AI agents for business. The most useful capabilities are being able to search among large amounts of our internal content, content that's not available in the web, it's private or proprietary content, and then to summarize that content and derive insights. Now, secondarily, we do have some text generation come out of this because we generate those summaries and we're generating thoughts and ideas from them. But the generation of text isn't necessarily creative in its own right. In AI agents, we like to have controlled generation from our content. And that gets into the next important part of discussing AI systems, which is, do AI speak truth? Do they understand facts? Do they know the difference between fact and fiction? And really, by default, when you talk to a chat model like ChatGPT, Claude, etc., out of the box, what you are getting is a generational text by predicting the most likely next word based on the training data it received. So the models aren't trying to lie to you, but they're also not trying to tell you the truth. They're trying to give you the best statistical understanding of what the next word should be given a prompt. And they're reflecting patterns from their training data without really any kind of intrinsic verification. Now, they are still very knowledgeable. They're correct lots of the times, but they also don't know when they're incorrect. And they definitely don't know anything about your internal businesses by the nature of not having that data to train on them, other than information about your public facing company or your public facing persona. They're not going to know anything proprietary or private about you. And that's where we get into how you build agentic workflows with large language models. And typically, you are building these workflows to accomplish a specific goal within your business. And instead of generating text by predicting the most likely word on the training data, these models are actually just using their foundational understanding of human language with all of that training data, but using your provided data and your provided facts to do the reasoning. And this is getting the best of both worlds. You get the capabilities of searching, summarization, and generation content, but you're putting guardrails on those features by using your own data and facts. There's a lot of techniques that go into doing this correctly, and we're going to dive into some of those now. The first technique, and this has been popular in the industry for, since the emergence of large language models, is the RAG architecture, or Retrieval-Augmented Generation. What this technique does is an AI agent, when given a prompt, searches over a specific content warehouse of data for data that matches phrases and likeness to whatever you asked it, and it returns that data. Then the large language model takes that data and generates a response. Now, the key difference here is it's focusing on using provided data rather than the training data the model was originally built in. In fact, you can do this today. If you go to many of the off-the-shelf chat models, you can take a PDF that you have about some content, drag it in there, and you can ask questions about your PDF. If you do that, that is a form of retrieval-augmented generation. It is retrieving portions or all of the PDF as you talk to the chat model, and the chat model is focusing on answering you based on what it finds. And the cool thing, and sometimes the dangerous thing, is it can use some of its external knowledge, phrases, understanding of the domain to help sound more intelligent, but it is focusing on trying to answer with data from what you've provided it. And that is the RAG technique. And the RAG technique is fundamental to most agentic systems. All of the patterns and tools and techniques we're going to go over in some form depend on the RAG technique working correctly and as you intend it to. So a lot of work goes into building RAG systems and to tuning them and to providing data that works. Now, when we are building an agentic system, the first thing you want to do is, well, I want to define the capabilities of my AI agent. And I'm going to use some examples in this presentation where I'm going to create a staff and project planner. That is, we're given a project that requires certain skills from my staff. I want to be able to find staff that work for me that could accomplish the project goals and complete the project, right? But there is a complication here. Everyone I have is working on a current project. They're not sitting around doing nothing. So I have to know when they're next available to work on a new project. And so this AI agent is supposed to help me plan when I can start and who can be on my next projects. And so we're going to go through these exercises of defining the capabilities I need at a high level, what knowledge bases my agent will use, the tools I'll have to integrate in, whether they're tools into just generic content or within my IT systems that help me run my business. And then we'll turn that around and design some ideas on how we'll build the agent. And finally, at the end, we'll have a full agentic workflow. First thing you need to do is prepare your knowledge base. Now, you may need a knowledge base in this example from your projects, information about your staff, like their skills, their names, etc. And you need to build a content index that takes all of that and puts it in a tool that the AI agent can search, right? Now, often that content will be PDFs, but it can also be direct database connections or in API integrations into third-party systems. And if they're PDFs or if they're database content, you extract the textual information from that data and you're going to put it into a search index that is specially designed for AI to search across. Now, when I say that it is specially designed for AI, that is because we use an AI search technique, and that is using vector embedding. Now, when we build vector embeddings, we are building kind of these word distances from concepts to other concepts. When you do a traditional keyword search, right, like in Google or other search engines, it's typically looking to match the word you search for with content it finds. What we found, though, in business systems, often we're not matching keywords, we're matching concepts. And what vector embeddings let us do is they measure the distance between concepts. An example is cat and kitten are concepts that are very close together, whereas dog and cat, they're a little farther apart, but they still have some proximity because they're both house pets, right? Which means they have even further proximity, but within the realm of, closeness to house. And you can consider that concept across a wide variety of domains. And that is where the foundational knowledge of the AI system really comes into play when it's helping doing a very effective search. Because even though it doesn't know your proprietary content, it takes all the words in your content and it develops these closeness approximations across all of your content. So it may find relevant information whenever you do a search. And those are called our vector embeddings. Now, we take these vector embeddings and the embeddings are generated from an AI model. So, even your software development team, they're not doing the math, they're not solving the equations. They're using an off-the-shelf AI product to create the embeddings. And they run their content over the embeddings model and put them in a vector database. Now, that could be a standard database like PostgreSQL, a advanced search index like Azure AI Search, right? Or it can be a specialized vector database for the task. And that database will be searched across for your content. Now, when we integrate tools, the searching of your content is a tool integration. But we need to integrate to solve this staff and project planner many tools. And part of designing your agent is, hey, what tool integrations do I need to have to integrate into my systems to find the data I need and to interact with those systems to do what I need to accomplish? To retrieve staff information, I may need to tie into my SharePoint directory. I may need to tie into my HR system like Workday or other systems to get the names and the skill profiles of all of my staff. I may need to go into my project system, like in Monday or in Jira or Azure DevOps or any other kind of planning system, to retrieve projects and the skill sets those projects required. And so I know when I can even start these projects, the dates of when my current staff end on those projects, so I know they'll be available for the next project. So I kind of have this complex planning task where I need integration to at least two separate systems and be able to search over the skills of my staff and the project skills to accomplish this staff and project planner AI system. Now, in agentic fundamentals, and we're going to go over several fundamentals, is having tools. One such tool that I'm going to consider building is a search staff tool. And the search staff tool is a RAG system. And I mentioned earlier, a lot of the tools in agentic workflows are going to depend fundamentally on the RAG technique. And searching across my staff is no different. I will have built a search database of all my staff and their skills. That way, if I type in, who is good at project management, I'm going to get a list of people who have project managing skills and experience. All right, so I have my large language model, and I ask a query, who has project management experience in a people to process project for a software development organization? So I need a project manager who can help me assign developers to projects, right? So the large language model is going to use the tool when I ask this question and search across my staff. It's going to get a list of results. It's going to compile that together, and I'm going to get an output. Michael and Lisa are staff members with relevant experience. Michael's a director with experience building software teams. He's built dozens of teams over 8 years. Lisa's a senior PM, 10 years of experience coordinating cross-functional projects. The chat system did a great job. It searched my staff system and returned me 2 different people who are relevant to this. Now, if I'm just talking with this like a chatbot, I could stop here. This got me a good amount of information. I have 2 people to go off of. However, it's not solving the whole workflow I was hoping for, which is actually seeing if they could be on a specific project and the end dates would align so the next one could start on time. So in order to do that, though, I'm going to need these systems to interact like an IT system. And that is, instead of interacting with text data like I'm a human reading it, I needed to interact with, an API schema like JSON, so other IT systems can just, understand and decipher my language. So one other fundamental to agentic techniques is structuring our outputs. And as software developers in AI, we no longer want to get our output from these large language models as normal text. We want them as JSON, XML, or some other parsable format that we can reliably parse into our systems and pass to other systems as well-defined outputs. And in this case, I need an output like, what is the name? What is their title? And I need a defined list of skills and an experience in years. So those are 4 attributes I need to extract in a very structured way that I can give to another system. And so this technique is about structuring your output from agents to be computer readable instead of human readable. Now, when you want to read the final output, of course, we'll still have that output in a text format. But right now, we're thinking about the interchangeable formats while the agentic system is still running internally, because it's going to be calling many tools and passing these attributes in a structured way from tool to tool and getting answers before it finally composes a final response. And so structuring output is very important in the middle of our agentic workflow. Going on to the agent design, we have a simple design. I'm getting a list of tools and I'm getting an output. But now I need to take the design and do the next part of the system, which is project assignment. So how do I design that part? Well, I need to have multiple tools. So one tool I have is my staff search. And I'm going to assume here that it was searching across SharePoint. And in SharePoint, you can have a directory of all your employees and their skills. They can have an About Me section, some experience. It's got all the fields I need. And that's where my company has chosen to store that data. And so I've built a tool integration to read that. into my tool pattern for the agent. But the next one I need is I need to look at my project assignments, which are in Jira. And so in Jira, I've defined my projects and what the projects are about, their goals, and the skills required to accomplish them. And so you can take your large language model, and instead of having it understand how to use one tool, you need to have it understand how to use multiple tools. And in the paradigms we have today with programming these AI systems, is we can teach AI and instruct them how to interact with these tools in the structured output way that I just described. So in this case, I'm going to ask my question again. And first, it's going to do my search staff tool, and it's going to get my staff. And then it's going to pass those attributes to my project assignment tool, which I've told the large language model, this tool accepts a list of staff members, and it returns the next availability based on their current project end date. That way I know when their current project is going to end and when they're available for the next project, which is my overall goal to create this staff and project planner. And we can see from this output, Lisa's the only one available to start in November, which was part of my query. And Michael cannot start because he's not available on December 14th. And you see in my structured output there, there's now one more field called available date, which I was able to append on my list of staff from the second tool. Now we get into a more complex part of agent design called routers. Routers have a very specific goal, and that is to make a decision such as a yes or no, or maybe a multi-part decision based on action or data from tools. So the goal of this router, right, is I want to find relevant staff and see if they're available. If I don't have staff, I need to hire someone. That means I don't even have anyone with the skill set, and I need to accomplish this project. So if I don't have any staff, I want to get a job description, and I'm going to take that description, and I'm going to go post it, hire someone. And if I do have staff, I want to be able to assign them to the project, right? So here, I now have added to my agent system a decision engine, and I can route based off of yes, no, or any other decisions I need to make down one part of the agent workflow or another. You can think of this as any other kind of process workflow diagram that a human process would follow, but we're teaching an AI agent how to follow the same process. And so we have to use all of the fundamental tools that we developed beforehand. We need to use our structured output so they can all communicate to each other. We have an escape valve for, if I don't have any staff, I have a way to exit gracefully, which is, hey, at least give me a job description. And in the successful part of routing here is I'm going to be able to do that assignment. The next important pattern, though, is supervisor, because I'm not quite done with what I want my workflow to be. And a supervisor is exactly what it sounds like. It's having a supervisor over expert systems that are good at one specific task. And in this pattern, I have a supervisor that knows how to ask really well, my staff search tool for those staff with skills, and another supervisor engine that is getting their availability end dates. And then later, I'm going to still need to be able to make the decision I talked about before. But the supervisor pattern is really useful because it can be run in a cyclical manner. So let's say that I have multiple staff that are needed. Well, the supervisor can do multiple staff from the search tool, and for each one, it would actually be able to get their project assignments in a loop. And you can train the supervisor how much to loop and when to end. In addition, let's say we have 5 experts. The supervisor can determine actually which expert is relevant to call at this time, because it may not need to call them all. Also, if possible, you can tell the supervisor which experts can be called in parallel to speed up performance to get to that answer faster, and which ones have to happen one step after another. The supervisor pattern is very common at the beginning of AI agent systems when it starts gathering information and building context over what it has to accomplish. And that leads us to the final part of our workflow, which is the entire design. So I'm going to start with a supervisor to answer the question of who has project management experience in a people to project process for a software dev organization and is available to start in November. So I need a project manager who can assign my developers, right? The supervisor has a prompt. You have an expert staff search agent and a project assignment agent you can use to help answer the user's query. So the supervisor, we've kind of prompted in a way that to tell it, you have experts available, and your job is to route questions of those experts to get answers. And it is going to do that. It's going to get those staff members, and it's going to get their availability dates. Now, at the end of gathering its experts, we have a router to exit the supervisor, which is, do I have staff available to complete the project? If not, we go to that same exit clause, which is I need a job description. I need to go hire someone. But if I do have staff available, then I'm going to do the final part of my tool, which is I'm actually going to integrate back into my Jira tool and I'm going to assign them to the project. And so what this agentic workflow has accomplished is I've said, hey, I have a project starting and I need these kinds of skills to accomplish it. It found the people I need. It found the ones who can start given the start constraints from their previous work. And then it automatically assigns them for me to the next project. And it's done all of that with a single prompt. That is the power of an AI agentic workflow. You can design these complex business processes that normally require some amount of human processing, and you can accomplish them, right? And you can build in workflows such as human in the loop, where you continue to provide further context and different techniques to continue putting advanced features in these AI agentic workflows. But they are able to accomplish kind of these medium complexity decision tree systems to accomplish workflows. When we take a step back and look at it in the abstract, right, we have the supervisor, it gathers data and perform actions. It takes it from those experts, right? Some of those experts are really good at looking up factual content in a RAG. Other experts are really good at gathering data from IT systems, right? Reading from SharePoint, from Jira, from your CRM, from your ERP. Consider all the things you could gather data from. And then you route to the actions you want to take from those data, right? Take the actions you want to take based on the data, right? You have your exit clauses, like if you don't gather the right data or some kind of exception happens where it indicates you can't complete the process. But if it can take the actions and it has all the relevant data to do so, you can even program these AI agentic systems to integrate in your IT systems and can actually update, take action, and do whatever is required in the work. And you design this in an intelligent way. You don't, always make the overall all-powerful AI agentic system. Your goal when you build these AI agents is to save people time so they can accomplish higher value work, right? Because this was a basic process. I needed to know if I had the right people and if the start dates align. That doesn't take, an expert person with a advanced degree. It just takes some project planning, looking at dates and aligning people to projects, right? That is something perfectly capable for an AI system. So that worker can then offload that task to the AI system, and instead we can accomplish something more amenable more meaningful while the AI system goes and accomplishes that smaller task. Now, when building these AI agents, there's these off-the-shelf frameworks that help us get started, right? And there's many to choose from, and I don't have strong recommendations over which one to choose, but you should explore them. You could even create your own, right? You don't have to use a framework off the shelf. You can have your development team build it all themselves. There's also low-code solutions that maybe are more drag and drop to build a AI agent decision framework. But you have LangGraph by the LangChain team, which is kind of one of those big first early large language model libraries. Microsoft has made a product called Semantic Kernel. OpenAI has just released a brand new agent framework called Swarm, which of course is tuned to the OpenAI models, GPT-4 and et cetera. Haystack, Llama Index, and Crew AI. These are all examples of agents, and there's more out there. This is really just a short list. that you can use to accomplish building these AI agent systems. And the way I recommend you choose is, have your teams prototype your ideas in them, see which ones have plugins to tools in your ecosystem that help speed along some of the integrations. Maybe some of them have a plugin to, Jira already or things like that. Others have commercial offerings that accelerate your time to market, like they'll host it for you if you follow their model. They have some premium capabilities you can pay for. Or maybe you need it to be open source because you need it to host it in-house, run it as you see fit. That may be a concern, and certain frameworks may be better tuned to that. And also, many of them have these case studies or use cases that they know people have accomplished with them. So if you see someone's accomplished something similar, that is a good way to choose, hey, that AI agent framework is a good one to pick. I like to kind of close out my message with these kind of talks, which is there's a lot of doom and gloom sometimes about, hey, AI is going to be bad for us. It may eliminate jobs and stuff, or whatever you like to think about it. What I like to tell people is embrace AI as your wingman. You are going to be a better worker, a better professional. You're going to be more accomplished at what you do if you use AI to enhance and optimize your personal workflow. It can help do tasks for you, it can automate things for you, help you analyze and interpret data. AI can help you do all these things so you as a professional can perform even higher level tasks, more valuable tasks. If you use AI as your wingman, you're going to have lots of great work to come in the years ahead. So thank you. I enjoyed giving this presentation. Please feel free to reach out to me on LinkedIn, email me at my email. I love to discuss these things. If you want to ideate a project, I love doing that. And again, at Improving, I help our partners create AI products. So if you've got a product idea in mind and you want to talk it out with me, please reach out. And thank you.
Thank you, Michael. That was awesome. I love that phrase, embracing AI as a wingman. I like that. So I already have a couple of questions for you. The first one says, you mentioned that accuracy in an agentic system is more reliable than using a default LLM because of provided data. But can't it still make stuff up?
Yes, it can still make stuff up. We refer to that in the industry as hallucinations. Um, it's a nice endearing term. So that there is a complexity that goes on, which is, even though your data is private and proprietary, it's going to have a lot of relation to training data that the model was based off of. And the model may try to make inferences or summarize things in a way that's using both, its training data and the information you provide it, which could result into a hallucination. Now, the likelihood is much lower, but there's a few things you can do to avoid this. One thing is, just in the prompt engineering techniques, you prompt in a way that says, hey, really only focus on the data. And if you can't find a relevant piece of information, don't say it. But what you can do on top of that I've been doing in many my systems, is I reference most claims in my AI agents. And so in this example of like the staff and planner system, you could have a references tab. And if you clicked on it, it could show you the real outputs of the staff search tool and the project assignment tool. And you could basically see a reference, sort of like a citation into something that you're citing that said, hey, I got this data from here, and here's what it looked like in the source. And oftentimes, even by asking the model to keep track of references, it maintains more grounding in facts. And if it's coming to some kind of critical decision that you want to double check on, you can click on that reference tab, look at the sources yourself, and verify it didn't hallucinate. Which, by the way, you really always should if it's something, even medium level important, because hallucinations are important. We're still encountering more techniques and ways to decrease them in AI agent systems. But just like, humans make errors, AI systems are going to make errors. They're definitely not perfect. They're still fundamentally rooted in statistics and probabilities. And so while they're more truthful, more factual in grounded content, you still have the possibility for those hallucinations and errors.
Cool stuff. Thank you, Michael. I have another one in the Q&A feature for you from Jim W. It says, have you built an authentic agent to respect data segregation on SaaS platform?
A data segregation in an SaaS platform. Okay, so I think that they're asking in a SaaS application, like software as a service, how to respect data segregation. And I imagine data segregation is like customer data. Customers don't want other customers to experience answers based off their own data. And yeah, that is definitely a concern in SaaS platforms. And it's actually not hard to do to keep segregation. It just takes good discipline. And the discipline is when I talked about building that search index, that RAG, you would build an index either per segregation source, like if it's per the customer, or maybe the customer's account, like their business account with all their users could use their data. You build an index for it just for them, and you connect each customer with their company's index. Or you have, one big index, but you have a filter tab that does a filter by customer before it does the search. Both have their pros and cons. But it just takes segregating the building of your RAG before you just let it out into the wild, if that's what you need to do for your SaaS product. And for multiple SaaS products, that is probably something that they have to accomplish is build some level of segregation of customer data, but in a way that on a software product perspective, the fundamentals aren't that much different than protecting customer data in non-AI use cases anyways. It's the same discipline of security and mindset of separating customer data as before. Now, a key here that you have to make sure you do, like let's say you're fine tuning your own models or even training your own models, though most people shouldn't be training their own models. You may need to fine tune a model per customer if you're using customer data to fine tune it, and make sure you don't fine tune a model based on customer data. If you do need to fine tune a model still, maybe create generic data that is not based off a customer. So you need to do those kinds of extra steps. But it's definitely possible. We're doing it today. I'm actually working on a project just like that today. And it just is the same security discipline mindset of keeping customers' data private from each other.
Thank you, Michael. Another one in the Q&A feature from Bon Jackson. Hey there, my friend. Have you found any help or support in writing better agents or writing the better workflow for our agents, keeping them in good order, although you gave a great example?
Um, I don't know if I found help or support. Everyone out there on the internet is doing it for the first time, just like I am, it seems, because, right, like I've only been building AI agents for 2 years, even though I have, 15 plus years of software engineering experience because they're new. But what I have found is if you break up your agents correctly into experts, into these graphs, and kind of my favorite agent framework right now is LangGraph because I can individually test the components of the agent. So I can test the tool separately. I can test the assignment tool separately, and I can verify each component is working as I expect. That way, when I put all these components together, I have reasonable confidence the system works. And just like you maintain functional or integration tests in a software product system, you need functional or integration tests in your AI agents. Now the key is it's hard to look for correct results because in a way it is non-deterministic in its outputs. Like they could change because it's AI and there's some randomness. But there's a lot of things you can do to control your test. Like, in the search tool in your test, you can have 5 people who match the test, 5 people who don't, and you should see 5 in the search results, right? And so if you really take time to control your test data, you can get to a reasonable expectation of having good tests over these systems. And I think that that's the best thing you can do is have test suites that test the individual components of your agent. And that will keep you sane as you advance capabilities, as you change the AI agent, and it doesn't vastly differ from how you expected it to be. Because without a test system, you're going to be like reading the output. you're going to spend a lot of time reading to see that it doesn't change for the worse over time because you want it to change for the better.
And the last one I have for you was sent through Teams, and it says, how are components and costs involved in an AI agentic system?
Oh, yeah, sure. So one component you of course need is the large language model, right? If you're using a commercial model like OpenAI's or Claude or any of those, you may be interacting right with a cloud service provider, them hosting the model. And if you're using an open source model, you can of course host it in your own infrastructure or on cloud infrastructure, but in a private way. So you do have the model cost, right? So commercial models are right now, except in the highest volumes, are pay per use. So you pay per every query. They're like so many cents, right? 1,000 tokens. If you're kind of hosting your own, you're maybe paying for the GPU hour. That's just a cost difference there. But the cost of hosting a standard software product applies here. So in AI agentic workflow sounds fancy, but at the end of the day, it's a software application that you host in a server somewhere, whether it's in your own infrastructure, the cloud. A lot of mine are just Python apps, right? They're a Python API because a lot of the AI tool sets are in Python. So how do you host a Python app? You need to factor that in. And the RAG systems, if you're building a search index, that's basically a database. So in all of your history of hosting software applications, how are you pricing to host your app server and your database? And then you just need to add on the cost of doing the model inference, which is kind of the new thing. So as long as you factor in the standard costs that we're used to in building software projects, and then you do the math to compute your cost of running the large language model, you'll be able to, with great accuracy, be able to determine your costs. Maybe the hardest part is just understanding, how often your users are going to use that product and how many questions they can ask a day. That way you can really understand the AI model component. But I think cost estimations are pretty straightforward to get to if you really plan out this as a standard software system, because ultimately that's what this is. It's a software system. You price out the individual components and you see what you're paying them up.
Thank you, Michael. I have no more questions for you. I don't know if you have any closing remarks before we say goodbye.
Just my closing remarks are, keep building these AI systems. If you're building stuff, feel free to tweet at me or make a comment to me on LinkedIn. I love to hear about what other people are building. I talked a lot previously how I built Improving Echo, which is one of Improving's internal AI agents, and hopefully shortly, well, more shortly, hopefully sometime next year, I get to announce what I've been working on the last year, which is a new AI agent system for one of our clients when it goes public. But until then, love to hear from everyone about what you're doing, and keep at it, and make sure you stay up to date because this stuff changes every day. And thank you.
Thank you, Michael. You heard here. Reach out to our expert through his LinkedIn page. And I want to thank you all for joining us today, but especially you, Michael, for such an interesting, useful presentation. And coming up this Wednesday, make sure to join Kevin Jordan as he continues with our Tomorrow Technology Today series with his webinar, Building the Enterprise of Tomorrow, Productivity through Gen AI Training. You surely don't want to miss it. Until next time, everyone, have a great rest of the day. Thank you, Michael.
Thank you.